Hello, this is Sarah Hardy at the University of Maine at Farmington, and this is a video tutorial in using R and Rcmdr to do data transformations with regression models. And so I'm going to show you two ways. First of all, doing it with Rcmdr, and the second way, just using R without Rcmdr. So I already have R and Rcmdr loaded, and I've already opened this data set XYDF, which is just some simulated numeric data. And I want to look at the relationship between X1 and Y1. So my first step, as always, is to make a graph. So I'm going to go over, and it's numeric data, so I'm going to make a scatter plot. And my X variable is X1. Y variable is Y1. Okay. And here's my scatter plot. We see that we do have a positive relationship here, but there's also some curvature in the data. So the next step is going to be to do a regression model. So I'm going to go to Fit Model. Linear regression. I have to be careful here because it's in the reverse order, is plotting. My response variable is Y1, and my explanatory variable is X1. And okay, overwrite model. Okay, and down here we see that our output from our regression model. Okay, so the next step, I want to do a residual plot. And I'm going to show you a slightly different way of doing it than in the earlier video. That's just a tiny bit easier. But first of all, when we make this residual plot, it's going to overwrite the scatter plot. So if you're exclusively using Rcmdr to do this, you'll want to save this scatter plot. So you want to copy it and put it into your Word file. Okay, so I'm going to go over and this is the slightly easier way to make a residual plot. And I'm going to go to Models, Graphs, Basic Diagnostic Plots, and Rcmdr will know to use whatever the most recent regression model that you made is to do these diagnostic plots. And it's going to actually give you 4 plots. In our intermediate class, we're not having time to discuss all these plots. We are only looking at the residual plot, but they all do contain useful, helpful information. So let's say that we want just to look at just the residual plot. We can actually do that by going up to the line that says Plot Reg Model, and I'm on Regression Model 12, but if you just were starting, it would be Regression Model 1. And I'm going to say which equals 1. And that's going to say I only want to look at the first plot. Okay, so I'm going to highlight that line, hit Submit, and now I can just get a bigger version of the residual plot. So again, if you are going to use just Rcmdr, you'll want to cut and paste this plot here into your Word file. Okay, another thing you can do if you don't want to do all that cutting and pasting now, although this can also get a little tricky, you can type in Windows and highlight and submit that. What that did is it opened up a second graphical window. So if I make another graph, it's going to come up in this window. The danger here is that you're going to end up with lots and lots of windows to keep straight. If you ever lose a window, you can always go to Windows, Cascade, and that will show all your windows. It's something that I end up doing a lot. Okay, so I just want to make another quick scatter plot here before we go on so we can look at both of these things at once. X1 and Y1. Okay. Okay. So in looking at the scatter plot and the residual plot, suggests that maybe I want to try an exponential transformation. So now, how do I go about doing that? I can go to Statistics, Fit Models, and instead of linear regression, I'm going to go to linear model. Okay. So down here, it shows, and I already did something, so that's why there's still stuff in here. You would first select your response variable to go right here. Okay. And this little tilde means as a function of. And then I can select my response variable here. It's really just as fast to type it, because at that point we're going to want to go over here and type exp x1, and then I can hit OK. I get my regression output here. Now I want to look at the residual plot, basic diagnostic plots. Pulls this up. Again, it's going to automatically pull up the panel of 4. This actually looks pretty good. If we want to take a bigger look at it, we can go back up to that line and type on it which equals 1. Okay. So this residual plot looks really pretty good, but it would also be nice now to look at a scatter plot of the transformed data. So to do that with the transformed data, we're going to actually have to create a new variable. So to do that, we're going to manage variables in active data set, compute new variable, and I've already done this once, which is why it's there, but I'm going to say exp x1 equals exponential of x1. Hit OK. And we can actually go, you can view the data set, and you can see that there's actually another variable there now, expx1. And so now I can go to graphs, scatter plot. For x variable, I'm going to do our new variable versus y1. Take that stuff out. Okay. And now you can see a plot of the transformed data. Okay. So again, you would want to be either opening new windows or cutting and pasting these over to your Word file as you go along. One note on if you choose to keep opening new windows, the Windows command that I mentioned earlier is only for PCs, I think. I don't have a Mac to try it with, but I'm pretty sure that the Mac command is going to either be X11 or cap X11 to do the same thing, and I think which one is going to depend on when you got your Mac. So I have not got a chance to test those out, so I'm not 100% sure that that's correct. Okay. So that is a lot of plot windows to keep track of, to be cutting and pasting into your Word file, and particularly if you have to try more than one transformation. So, okay, as it turns out, the video on transformations was too long, so I'm cutting it into 2 pieces, and I just wanted to make this little clip to to put at the end of part 1, and then part 2 will show how to do the transformations using regular R without Rcmdr, which I think you're going to find to be a lot easier and a lot more efficient. But before I leave this video, I want to actually correct one thing from a previous video. And to demonstrate this, I've actually loaded in the Redbox 2010 data. And what I want to show is how to include more than one variable. Okay, so let's say I want to fit a model. I'm going to go to linear regression, and let's say I want to look at batting average as my response variable, and I want to pick out a couple of these variables. So let's say I want age. What I have to do to select more than one is use the control button. Okay, so let's say I select age, on base percentage, runs batted in, salary, and I'm just picking out some stuff here that may not actually make much sense. But anyways, I'm going to say OK, and then that will give me my model with more than one explanatory variable. You can also do the stepwise regression in Rcmdr, and to do that, you can just go over to Models and Stepwise Model Selection. And in class, we only talked about backward regression. This actually gives backward and forward, and then there's combinations where you go back and forth. There's two criterion here, which are more advanced criterion than what we talked about in class, which was just using the p-values. So, for example, you can do backward, hit OK, and it will show you that it started out with all those variables. So at first, then it dropped out. Looks like it dropped out salary first, and so on and so forth. So it might be interesting to try this and compare it to the methodology just using p-values. Okay, and one more quick thing to show you that I didn't ask you to do in an assignment, but some of you may need to do this for your project, and it makes sense to do it right here because it doesn't make any sense to talk about batting averages for the pitchers, and they're included in here. So how do we exclude them? So you can go to Fit Models, Linear Regression, just like we were doing, batting average with whatever variables we decided we wanted. I don't know what they were, but so let's say we want to exclude the pitchers, and you can go down to your subset expression and say position, which is the name of the variable, bang equal, that's exclamation point equal, means not equal, pitcher. And we did something similar on a previous assignment. The same idea works here for linear regression. So now the model that we do now will be without pitchers. Okay, so that's the end of part 1, and the video will continue in part 2 with how to do the transformations just using R and not Rcmdr, which I think you'll find to be much, much easier and quicker. Okay, so that's it for this video. Bye, and thanks for watching.